machine. We were discussing about some terms related to machine. Number one, load. What was load? Actually, load is the large resistive force that is to be overcome. Effort. What is effort? Effort is the force. This is load. This is the large resistive force, opposing force that we have to overcome. And effort is the force applied on the machine to overcome the load. Effort is the force applied on the machine to overcome the load. And then I told mechanical advantage. What is the meaning of mechanical advantage? The ratio between load and to the effort is called mechanical advantage, since it is the physical quantity, since it is the ratio between the two similar physical quantities, so it has no unit. And if mechanical advantage equals 1, then it means load equals effort. It means this machine जिसका कि mechanical advantage 1 होगा, उसको हमने change in the direction of application of force के लिए, जैसे single pulley. And if mechanical advantage is greater than 1, it means load बड़ा है, effort छोटा है, it means ये force multiplier. और अगर mechanical advantage is less than 1, it means हमें force multiply नहीं हो रहा, speed multiply हो रहा है. One more thing, a machine can be used as a force multiplier, as a speed multiplier, but it cannot be used as energy multiplier. Why? Because energy neither can be created nor can be destroyed. See, velocity ratio. What is velocity ratio? The ratio between velocity of effort to the velocity of load. The ratio between velocity of effort to the velocity of load. Suppose in t seconds, the effort point मतलब क्या? जहां पे हम effort लगा रहे हैं, that is effort point. जहां पे हम मशीन में effort लगा रहे हैं. And load क्या है? Load point क्या है? वो point जहां पर हमको load, जहां पे load लग रहा है मशीन का, उसे बोलते हैं load point. Suppose in t seconds, effort point is displaced by dE and the load point is displaced by dl. What is effort point? Distance of means effort point होता है वो point जिस point पर हम मशीन पे effort लगा रहे हैं, और load point वो point होता है जिस पर मशीन load पे force लगाती है, उसे बोलते हैं load point. Yes. So then velocity of effort, what is velocity of effort? dE upon and velocity of load dl upon t. So we can write velocity ratio v upon vl means dE upon t upon dl upon t. We can write what? dE upon. So the ratio between displacement of effort to the displacement of load is called what? Velocity ratio. And if mechanical advantage is 1, then velocity ratio is 1. If mechanical advantage is greater than 1, then velocity ratio will be less than 1. If mechanical advantage is less than 1, then velocity ratio is greater than 1. इसका मतलब जो speed multiply है उसका velocity ratio 1 होगा, जो force multiplier है उसका velocity ratio 1 से कम होगा, और जो speed multiplier velocity ratio 1 से ज़्यादा, और जिसमें change in direction है उसमें velocity ratio 1. Yes, one more thing. Efficiency. What is efficiency of a machine? Efficiency, the work output by machine upon work input. Work output upon work input. The ratio between the work output to the work input is called efficiency. And work output, what is work output? Work output is the means work done by machine on the load. And work input, work done by effort on the machine. See, work output, work done by machine on the load, and work input, work done by effort on the machine. And work done, work output, work output, it will be work done by machine on the load. It will be means what? Displacement of load point into load, work equals displacement into force. And work input is what? Displacement of effort point into effort. So efficiency equals, we write efficiency equals eta. So eta equals work output upon work in. For an ideal machine, efficiency is 1. For an ideal machine, efficiency is 1, but for the practical machines, output cannot be equal to the input. Why? Because whatever the work we do on machine, whatever the work effort does on the machine, some of its part is spent against friction, movement of movable parts, elasticity of the strings, weight of the string, weight of the pulley, etc. So always efficiency of machine is less than 1. And if you want to find this efficiency in percentage, then work output upon work input into 100. Got it? And efficiency has no unit. One more thing. Work output equals displacement of load into load. Work input, displacement of effort point into effort. We can write load upon effort, and then dl we can see de upon dl. No change, na? That's same, means load upon effort, de upon dl. We load upon effort, we can write mechanical advantage, and de upon dl, that is what? Velocity ratio. So efficiency equals mechanical advantage upon, this is the relation between mechanical advantage, velocity ratio, and efficiency. This is the mechanical advantage ratio between efficiency, mechanical advantage, and velocity ratio.